Implementing the OcfEmbedded protocol by Objectis. If you've ever worked with embedded platforms, you know how cumbersome it can be to debug your applications. You usually have to resort to using a console, LEDs, or debuggers, which require you to halt the execution of your program. What if there was a better way? Today, I'm going to introduce you to the OcfEmbedded protocol. Combined with oStudio live tuning, it allows you to remotely inspect data in your program instantaneously. OcfEmbedded comes as a lightweight set of functions that allow you to easily publish any variable or function you desire. All you have to do is write the interface to connect OcfEmbedded to the debugging machine via serial communication, UDP, or just about any protocol you want. To show you how simple it is, we are going to implement the OcfEmbedded protocol between oStudio live tuning and a small C application on your computer. If you haven't done so, please watch our first video that explains how to get started with live tuning. OcfEmbedded comes as a tiny package including only 4 files which are standard ANSI C. This means it's completely platform independent. Working with UDP for OcfEmbedded is extremely simple. To show you how simple it is, there is a sample application called Simple UDP that we will complete with just a few lines of code. You can download it on the OcfEmbedded page on our website. My application already has a couple of variables and functions that we'd like to access from oStudio. What we're going to do here is define exactly which variables and which functions we want to publish. Just above our main function, we will use the macros which are declared in the OcfEmbedded files we have included. We first start by creating a list of entries. This creates a variable called OcfEntries, which we will use later on. Now, we're going to actually write which variables we want to publish. This is also done using macros. We start with the variable a of myStruct, which is of type integer. Then, we move on to variable b of myStruct, which is this time of type long. We finish with the variable c, which is a global variable and is of type integer as well. Now, we can implement the function increment a. This is done using the OcfE function void macro. So, we just write OcfE function void increment a. This concludes the declaration. We just need to close it using the OcfE end macro. All that's left to do is to call the function called OcfE execute every time we receive data. The code in the sample already takes care of receiving and sending packets. If we scroll down a little bit, we see that there is a comment that tells us where to put it. Before passing data to OcfEmbedded, we need to receive it. This is done using the receive from function above. Then, this data needs to be passed back to the client. This is done using the send to function below. And that's all there is to it. You can compile and run your application now. With your app running, you can launch live tuning and add a new embedded UDP connection. The default parameters should do. Now, you can see that the variables you declared earlier show up in the tree structure, and you can play with them however you want. If we call the function increment a by double-clicking it in live tuning, we can see in our console that the function has indeed been called, and the value of a has been incremented. You can see how OcfEmbedded works both ways and provides a true communication protocol. This concludes our training session. Try it on your own embedded platform. We already have a few examples for select embedded platforms such as Microchip and Scilab's development boards, which you can find on our website. In just a few minutes, we've implemented the OcfEmbedded protocol. We hope you'll enjoy using OcfEmbedded on your own project.